if you see from sklearn.neighbors, we imported k neighbors classifier. So this is a one kind of classifier. K nearest k, the value of k you can give whatever 1, 3, 5, whatever. Okay. Based on that, it will try to find which is the nearest value he which can model predict to which can model choose to predict the result. Okay, so here n neighbors means this is a sample. Okay, matrix, this is a Minkowski, uh, we can say the distance between how we can calculate the distance between the main point to the neighbor point. Okay,
Okay, sir.
and this is the way by which distance will be calculated, p23. So there is one Minkowski, then Euclidean distance calculation formula. So based on that, it will be able to calculate it. Then I think I had some theoretical notes as well. So this is a predictor part. So classifier dot predict method, we are trying sharing the x test result and it is predicting value. Then we are using a evaluation method like confusion matrix from sklearn.matrix, import confusion matrix, variable cm equal to confusion matrix, and here we are providing value of y test data and value of y predicted data, means this value and y test, where is y test, this value. Okay, then after that we are visualizing those data. So this is the same thing, no change, only the values are different. So matplotlib color, listed color map, x test, y test, we assign to x set, y set, x2, y2 is a variable, then numpy mesh grid. So this is a start value, this is a step value, and this is a step. Then contour, classifier, predict, numpy, ravel. What the ravel function do? Hello, am I audible, Siddesh?
Yes, sir. What?
What ravel function do? This ravel.
Sir, actually, yeah, we can say like it displays the in like what we can say like into the two-dimensional array. We can say like
One, it will make into one dimensional array. Like here
yeah,
is
yeah,
a
yeah,
value
yeah,
of one and
yeah.
one value two. Okay.
Okay. Into
Then
one dimension. Yeah.
and t, why we are using t here? I explained in the last session.
Uh, so I think I forgot it. Just a
Okay.
second, I will just note down.
T stand for transpose. So we will transpose this rows into column and column into rows. Okay. Fine.
Yeah, sir. Means we are just transforming the rows into column and column into row. Okay. For that,
Yeah.
we have used
For that purpose, we are using T. Then we will reshape it like if it is a three rows, three column, like we will reshape it. Then here also we are using alpha. Why we are using alpha? We saw the example of degree earlier.
yeah, sir. Degree
So similarly,
for
alpha
the
also we are,
SVR.
yeah, so it is kind of degree like as a 45 degree, 55 degree, 70 degree, 75 degrees. So we will plot it based on how many degree our prediction of a model is almost accurate. Okay, so this degree can vary. You can, based on your data, you can vary this degree, and this is a color listed map, green and red. This is a limit for x limit, y limit. It will take a minimum from x1, max from x1, then minimum from x2, max from x2. Then this is a for loop for I, j in
Sir,
enumerate.
could you please repeat that alpha definition, like alpha definition?
It is a degree, like when I have not run it. So let me run and show you on a graph. So what happens, the graph which we are taking here 75 degree, this is on training set. Okay, similarly we are here taking it for test set. Let it load. So when our graph will get drawn, so we will try to check this degree. So this is a line. Based on that, we will try to uh, vary our degree. So we'll check here with example. So this is for training set. Okay, just keep monitor this, and this is for test set. Now here let's change the degree to 65. Okay, I am doing it for this is the test set. So this is the graph. Okay, second graph I change it to 65 degree. Now let's run it. K nearest neighbor, or KNN. In short, we refer as KNN. This is the first one, first graph, which is for training set. Testing set, it is loading. See, is there a slight difference in this graph?
Yes, sir, we can say.
Okay, let me do it for the first one. So just monitor here for monitoring purpose. 2, 2, 4, 5,
3.
6, 7, 8, we can say. Here is 5 and here are 3, which is coming on this side. Okay, let me move it to 55 degree. Okay, it's loading. Running the program. See, 5, 6, 7, 8. Sum of the degree. Yeah, sorry, we are applying this not for data, we are applying this for color. Okay, so due to that, if you see, the color is impacting, right?
Yeah, it is light, we can say.
Yeah, light. So this alpha we are applying for color. Okay, let me make this 75 and rerun. We'll keep our cursor here. Color. So this is the color which we are getting. I think here we have given the different color. Okay, so by our bare eyes we are not able to identify much difference, but it is giving us the difference. Okay,
Yes, sir.
here it is not explained. Okay, the alpha blending value between 0 transparent and 1 opaque. Okay, so this is the one. So value or the display which we are looking now, so it will vary between 0 and 1, and if you make it 0 it will be totally transparent. We will not be able to differentiate between the actual value and this one, and if it is close to 1, okay, let make it 0 and 1 and try. I'm making 0 to this, and let's make it 1 to this. See, now you are getting?
Yes, sir. Like means one is darker, you can say.
Yeah.
And test
So
data, yeah, it is
yeah,
running.
it is loading, and this is for training set. See, got it?
Yes, sir.
So we are not able to differentiate if we give such thing. Due to that, we have used 75. Now this parameter value is clear.
Yes. It is
Okay.
for color only, mostly, you can
Yeah.
say.
Like degree in there we were doing degree, so it was banding. Similarly here we are using full color, so it will give us some such kind of clear color. Like if you see here also the red dots we are not able to identify on the red side, right? On right side we are able to see some red dots are there, but there were some dots in red side as well, which is
Yes,
not
sir.
visible. And here also we are not able to identify from where we have to make a separator, so that separator is also not visible here, right? Now this KNN concept is clear.
Yeah, so that mini course key.
Okay, let me go to the theory part. Let me come here. K nearest neighbor is a simple supervised machine learning algorithm used for classification regression. So we saw earlier for regression, this is for classification. It is mostly used for classification problem. It works by finding the k nearest data point to a new data point and making a prediction based on the majority level of classification or the average value for regression. So let me open the paint, so I will be able to show you there. My paint window is visible to you.
Yes, sir.
Okay, let me draw this. Suppose you have this data. Okay, now let me go to some dots. Okay, one, two, three, four, five, six, 7, 9, 10. Fine. These values are clear.
Yes, sir.
Okay. Now let me see. I have value. I predicted this as a k. Okay. This is my k value. So I have to calculate a distance. So if you see nearest for from this point will be this
That
one,
one, yeah.
then this one, this one, we can say this one, right? So
Yes, sir.
whatever the sample data, there are other value also, but these are too far, correct?
Yeah.
So k nearest neighbor is this one. There will be 1 point data, whatever the value took it, and here we took 3. Here the value of k is, wait, 5. We took a 5 value, so this is the 5 data point, and based on that how we will measure the distance. Okay, so measuring a distance there are multiple, like Euclidean, mini QSK, which we have seen. So this diagram is clear for now.
Yeah, so like we can say like means we are just finding so the nearest what we can say like values from the means from
Like
our real data set we can say.
you will decide this one and where
Okay.
this value, and based on that you will try to calculate the nearest neighbor. Okay, so nearest neighbor, how you will find? Maybe based on formula, because this is with our bare eye we found these five values are nearest. Okay, and calculating method is different. Let me switch to Colab. Okay, so my Colab window is Chrome window is visible
Yes,
now.
sir.
So
Yes, sir.
this is
Visible.
the sample. You can say this is a sample. Okay, this is a matrix. Okay, and this is the way by which you will be able to calculate. So there is a mini kiosk definition. So mini kiosk distance is a generalization of several distance metrics. Okay, including Euclidean distance and Manhattan distance. So these are ways of calculating a distance. It is distance measure that can be used to calculate the distance between two data points or points in any n-dimensional space, where n is the number of features. Okay, number of samples or number of features. So here we given p equal to 2. Okay, so if you see in a code matrix, we are looking for mini QSK, and here we have given p equal to 2. So for p equal to 2, it do the Euclidean distance approach. So the mini QSK distance become the Euclidean distance, which is the most commonly used distance measure. If you make p equal to 1, it will do the Manhattan distance. The mini QSK distance becomes the Manhattan distance, so also called L1 distance or L1, L2 like that. Now clear why we are using this p equal to 2?
Yes, sir. Like means when the p is 2 we have to use the what we can say like the including or the mini kiosk and the for p if equal to 1 then we have to use that
No,
other
no, no.
one.
What happens now? Like I'm not getting a right example to explain. Here matrix we decided mini kiosk. Okay, so in that there is one Manhattan, there is one Euclidean.
Include yes.
So if you just due to the value of p, these distances are changing. So here mini kiosk we given p equal to 1, so it will refer as Manhattan distance
Manhattan.
approach, and if you give p equal to 2, it will go as a
Include yes.
Euclidean distance. Fine. See, so the if you see 538, not much, but this time we are using p equal to 1 means Manhattan distance, and by that we are getting these values. Fine. So 1, 2, 3 here on test, and here 8, 5, 3, 8. Now observe for 2 p equal to 2. Almost distance will not much make difference because based on that we are using KNN now. In our personal system, if we try now, then we get very slow response. This is for training. Yeah, almost. Okay, okay, not much difference. Okay, here also three values are coming on left side. Here also eight values are coming on next side. Fine.
Yes, sir.
So that is a distance measure technique. Now KNN is clear to you?
Yes, sir. So it
Any
means just a second, like that one means could you please scroll a little bit upwards, like that KNN. Oh, yes, yeah, yeah, yeah. So that K neighbors classifier is a class, no, and for that inside that the parameter like we can select the n numbers. N neighbors means how many datas we can say.
yeah, yeah, sample,
Okay,
and
okay, yeah,
neighbors.
got it, sir.
Okay. Then we'll move to next one, which is support vector algorithm. Support vector we saw in regression also,
Yes, regression.
but here we will use it for classification. Same thing here. We are doing a library import, numpy, matplotlib, pandas. Here again we are importing a data using pd, pandas, setting into dataset, extracting x and y. Same thing like we are making a test and training dataset, split, feature scaling. Why we use feature scaling?
So basically, it's an what we can say, like it's an
Sorry.
yeah, yes, sir. So basically, it's an the way to know where to normalize uh the 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 the, the data, no, like we can say uh to make it in to the scalable format, we can say.
Okay. Then fitting. So we'll see the kernel part also. So
Okay,
fitting
kernel.
SVM, support vector machine to the training set. So from sklearn SVM we are importing SVC. Earlier we have saw it was SVR, right?
SVR, sir.
Earlier. So support vector regression, and this is classification. Okay. SVC, then this is just a variable name classifier SVC kernel. In kernel there are many types as well. So this is a linear kernel, and random state equal to 0. Why we use random state equal to 0?
Basically, we can say it's for yeah. Basically, we use this the random should equal to zero. If we haven't used it, then it will just what we can say display the outputs in a random what we can say like a random output. So for fixing it, we have to use a random state.
Okay, then here we are fitting the value of x train and y train. Here we are predicting y predict equal to classifier dot predict x test. Confusion matrix. Why we use confusion matrix?
Yeah. So basically, it's an true false can say like yeah.
Evaluation methodology, you can say, or evaluation technique. Okay,
Okay.
how this will be evaluated. So sklearn dot matrix import confusion matrix, and here if you see we are providing a value of y, not x, right? For feature scaling we provided the value of x, not y. Getting a difference?
Sorry, sir, what?
For feature scaling we are providing a value of x, not
X12,
y.
yeah.
But for confusion matrix, we are providing a value of y, not
Y
x,
test.
right? And
Mm.
here, if you see y predict, the predicted value based on the X we are storing into Y predict, not the direct X, right?
Okay.
So Y test data is normal, we have not done anything. And predicted value of Y based on independent variable we are passing for confusion matrix. So like we say model evaluation kind of thing, right? Based on model we evaluate our model is performing good or not, right? For that purpose we are using confusion matrix for evaluating our model. Fine.
Yes.
And this is the same repeated code, matplotlib color x set y set x1 x2, same, no difference, code is as it is. This is also the same one, only value will be different. This is the same for loop, no change. Title x label y label legend, and here we are providing x test y test. Here we provided x train y train, training data set and testing data set. Let me run. So this is our data. If you see, we are using, this is SVM regression, but sorry, classification, but we are using, where it's called, kernel linear. Okay. Now let me try instead of linear. Do you think on this data set linear kernel works well?
Um, yeah, yeah, so but it's not a regression, no. It's a classification.
Sorry.
Yes, sir. Actually, it's well we can say like it's good we can say, but it's not like we can say like we
100% accuracy, don't think about that for now. Okay. Apart from that, try to evaluate.
so actually in that SVR regression we have used the kernel RBF.
Hmm. Okay.
So here we are using the linear.
Okay.
So yeah, we can like if, like means by by viewing the output we can say like it is clear now because only 1, 2, 3, 4, 5, 6, 7 values are there. You can say in test data. That's
Left
good.
side value is not predicted well. If you see, it should come to right side, right?
Yeah.
But what happens? Suppose you have a data set in this graph format, and you are doing a linear. So linear is great possible result. And if
Hello.
you
Sir, could you please repeat because I'm not able to hear you properly. I
now
think
is
there was a yeah.
am
Sir,
I audible?
still hello.
Yeah, yeah. Am I audible now?
Yes, yeah. Now you are
Okay.
audible.
So if you see this linear part based on our calculation of a model, it is starting from this part and ending on here. So if we shift this to let's say more this side, so instead of providing more accuracy for our green dot, it will also provide less accuracy for our red dot, right? Because there are some red dots also will come if this line start from this and it will go end here,
Yeah,
right?
yeah.
So our model trying to predict as much as possibly accurate result, but it could not be 100% accurate. Now, can we try polynomial or RBF here? Let's try. Okay, now I am using RBF kernel. See how our graph is designed now.
Okay.
Getting? So this is our training data set graph and this is our testing data sets. So you can try which kernel will apply more or less. Can we apply polynomial here? Poly. See, poly is not working well, right? Lots of unpredicted.
Yes, sir.
Then one more is there. We saw linear, RPF, poly, and one more is sigmoid. See, it is totally different. Like it's not providing us the accurate value.
Correct value, yes, sir.
Okay. So from all these four kernels, which one looks better?
Linear one.
Linear only,
Linear and RBF.
right? Or so when you will keep trying and analyzing those patterns, no? You will provide different kind of data set. Based on that, you will be able to. This is our training. Okay, so if you see, not much. Okay, based on RPF, it is giving 3 here and 4 left side. Almost you can say it is predicting. Okay, okay. And let's come to linear. This is training for linear. Means training is linear is not giving much result, right? Hello.
Yes, sir.
Poly also not working well. Only RBF working well, right?
Yes, sir. RBF only. Yes, sir.
We can try and evaluate our models and based on our training visualization and our testing visualization we can predict. Fine. So
Yes.
SVM support vector machine is a classification. It is clear now.
Yes, sir, we can.
Okay. Now I have given you the assignment till where?
Yeah, so it is like just remaining consider the decision tree and the random forest were remaining
Decision tree.
and random forest. Yeah.
Okay. Simple linear regression given
Yeah,
polynomial regression given
just a second. Just a second.
SVR support vector regression
Yes, sir.
given decision
Random forest given, decision
is
tree given,
ran-
SVR given.
random forest given.
Yes, sir, given. It is also there. It is the last one. You can say.
Okay. Then logistic regression was there. I think five. No, I forest. In that one is for data pre-processing. No, one is data pre-processing. I have given five. I remember. Then simple linear.
Yes, sir.
Then polynomial.
Then support vector,
SVR.
decision tree, and random forest.
No, random forest. I think I have not given.
No, sir, it is there into the chat box.
Okay. It is for random forest. Okay, let me share the then different one, logistic regression. Okay, this is for logistic regression. I am giving on a chat. And KNN. Okay, we have covered the KNN. One more, SVM. Okay, today we covered. See, code you will get it, but try to understand the concept. Okay, not always use chat GPT. Fine, because you will get a ready-made details. When you are stuck, then use it. Hello,
Yes, yes, got it.
fine. Because ready-made thing, if you will get, then how you will be able to brainstorm? When you are stuck, then it's fine. So we'll not cover more. So I will stop here till SVM only. Till here, any doubt, any question to you?
No, sir. Sir, actually, I mean, just want to ask, like, first we have saw what you can say, like, the data pre-processing, the linear regression. After that, we are just showing like means it means we are just seeing the classification. So
Hmm.
means like, are there any rules like first we have to do the data pre-processing, the linear regression, then classification, then after that we can say like the visualization, or else like, is
No,
there
no.
any set of rules?
Data processing is mandatory step, we can say, because
Okay.
most of the real world data is not in a proper structured. Okay, so data processing you have to do. Then based on your requirement, you will decide which kind of model you should apply. Suppose you want to differentiate. Let's you have an example for predicting how many late males are in one of the crowd, you can say event, and how many males are in the event. So how you will decide? So you can simply predict. That is a classification, we have to classify, right?
Oh, sir, but I'm not getting it.
Okay, let me give you the example here. Assume this. Okay, as you have an event, and event people are coming like, okay, we don't know how many males are there, how many females are there. Okay, fine. So see, on any of the event, people have participated. So we have to differentiate how many males are there and how many females are there and segregate it. Okay. So by this requirement, what you should apply? You should apply regression or classification.
Yes, sir. Like, I can say like we have to use the KNN algorithm here, like for the classification. Like, we can take the what you can say, like the nearest neighbor.
No, in that we will not apply na KNN. Why we will apply KNN?
Okay.
We will try other algorithm also. No, KNN will do whatever the closest from our one of the data point which will predict. Assume this whole chart as a room. Okay, hold this notepad as a room. Okay,
Yeah.
in room these members can be anywhere. Somebody can sit here, somebody can sit here, somebody can sit here, somebody can sit here, anywhere, right?
Yes.
By looking into our data, it is fixed that we can take a probability that any of the classification algorithm will apply, right?
Yeah, we can say.
Then we will try which classification algorithm giving us the best possible accurate result. Okay. Then you will do the model
Yes, sir.
evaluation. You will evaluate your how model is predicting, and initially we have to look on the data and the result. Then we will be able to decide which is the best one. But when you get
Yeah.
more experience, then you will be able to guess it accurate result, like which model we can apply when, or which kind of data set.
Yeah.
Fine.
Yeah.
KNN, I will give my experience. Like KNN, if you see, there is a bunch of something which is closer to one of the data points. So you can simply predict, yeah, this is KNN we can apply. One of the data point can be picked and closer values. Okay, let me give you this example again. My paint window is visible to you.
Yes, sir.
Okay, I'm erasing this. Now I have this rooms here, and small dots I will make it. Two kind of dots I will do. So one is square and one will be circle. Okay. By this data, what you will be able to predict that uh, which we should take. If you see, if we
Uh,
take a old one, means a
okay.
circle part, circle is here also. Okay. But if we look into this part, circle is more. Might be
Circle more, yeah.
this circle can be missed with our model. Circle is here also. But there is a probability if we focus into this part, we will be able to capture more circles, right?
More circles, yeah. Yes, sir.
So we can apply the KNN. We can predict this could be one data point, and based on that, our model can predict. There would be less accuracy than normal, but it will give us the most probability. Now, if we look for this dot one, means square bracket, it can also pick this one, right?
Yeah.
Some of the dot square bracket will be missed, like here. But majorly, if you have to predict the square bracket, we can go here, correct?
Yes. Yes, sir.
So based on our data, if you look into the data, based on your experience, you will be able to analyze quickly which algorithm we can apply when. Okay, suppose we somebody come to our home. Okay, we served some, let's say tea. So tea, as per our past experiences, we know tea we will give into some of the cup, not on a glass, right?
Yes, sir.
But we can give tea into glass as well. Is it feasible?
Yes.
Right? But as per our normal standard, usually tea is served into the cup. Similarly, when you apply the algorithms, and you will come to know at which time, on which kind of data, and on which scenario, and based on requirement, which algorithm we should apply.
Yes, sir. Got it.
Fine. Any other question, any other doubt?
Yeah, sir, could you please like means also explain the what you can say like the logistic regression with like means like that example in paint we can say.
Okay. Just give me a second. Regression. Okay, it is a classification only. My collab is visible to you, right?
Yes, sir,
Hello.
it is collab. Yeah,
Okay.
collab is.
Pressing this, let me run. This is the same thing. So here, what you want to see? Like there is nothing extra parameter, normal only.
No, sir, no, sir. Like, means I understood the code, but I just want to means now you have explained me the KNN by using the pen, no paint.
Hmm.
Yeah, so it is easy to understand, like
Okay.
into the visualization.
In here, na logistic, it is giving us a linear model only. In linear, let me explain that. Linear is simple now. Just you have to decide where to draw the line, and model will draw.
Okay.
In linear, there is no itch no. My paint is visible.
Yes, sir.
Okay. Let me select and remove this. Fine. So I will take this first. Suppose we have this data, and we'll take a small dots. Logistic regression is a classifier. Okay.
Yeah.
So these are our data. Now, if you have to do the classification of it, which line you will predict that which can give us the best result?
So like from the center we can say
How? Just okay. Let me big.
because it means there are more circles we can select more data.
No, not on data. We have a two type of data. One is black and one is red. Okay. So I will make a big red so you will be able to identify easily. Now tell me. We have a red and black data set. So our line should predict from where, means uh, from where our street line should go. So it can give us the most probable accurate result.
Uh, yes, so like we can say if it is linear, yes, means could you please tell like not getting it?
See, I am just taking from here. So in this case, it will be able to give us the more accurate result for red circle.
Yeah, we can say like
On left side, there are 1, 2, 3, 5, 6, 7 red
four, five
circles.
only. Yeah.
On red side, there is more than 8. Correct? So it is more accurate for red. If you look for black, then it could be not right. Maybe 3, 8, 10, 15, 16, 17 are on left side red, black. But on right side, how much? 3, 3, 8, 9, 10.
16, 17 are there.
Yeah. So almost we can say 50, 50. Okay.
Uh,
So like that, our model based on our approach, it predicts. Okay,
Yes.
fine now.
Yes.
Any other doubt? Any other question?
No, no, sir, no.
Okay, so we'll stop here today. Thank you. Bye.
Yes, sir. Thank you, sir. Have a good day.